Hi everyone, so today we're solving the week 3 chemistry quiz. So first question, it's asking you which of the following symbols refers to the heat content of a subject. It's H and just memorize it as it is. It's not anything solving. For the next question, they're asking which of the following are examples of endothermic processes. This was the same question came last week, so I told you that it's going from solid to liquid to gas in this way. It's endothermic, and if it's coming from gas to solid to liquid, it's exothermic. N means endo, X is exo. See? Endothermic, exothermic. So let's see. Reacting NaOH with HCl. This one is exothermic because this is a base and this is an acid. You know, because here there was an OH and here was an H. So base with acid makes a neutralization reaction, making them balance out, which becomes, it's exothermic. Just memorize when you see a base and an acid, it's exothermic. Heating. What's heating? Heating is going from a solid to a liquid. See, water vapor to gas. Or actually here it's liquid to gas, sorry, my bad. So liquid to gas, either way it's heating and it is endothermic. Cooling, water vapor. A gas to a liquid cooling it, it's exothermic, so no. Melting an ice cube is melting from solid to a liquid, which is endothermic. This question came last week and it's easy. So next question. Okay, so for this question, it's asking you which of the following energy diagram is for an endothermic reaction. So this is your correct option, but let me show you why. First of all, it's always going up. It's never choose the ones going down. Now, why is this one? Because see this picture, for example. Waiting for it to open. Anyways, I'm just gonna enlarge it. See, when you have your... Okay, here it is better. When you have your... What's happening? Okay, so here as you can see, when you have the reactants and the product, draw a line connecting them. If you see the line going up in a positive slope, it's endothermic. But if you're going see down like this, it's going down. This means it's exothermic. If it's going up, it's endothermic. So now, going back to our question, here, see, the slope is going up. So your answer is this one because it's endothermic. Now for question 4. It's Hess's law. So we have to calculate, we have to find the heat formation of this of CO2. So for this question, you're going to look at all 3 of your reactants. First of all, you're going to write down on your paper what you need, which is here. This is what you need. I'm going to change the highlighter color because I don't like it. Anyways, so now you write down your 3 reactions and what you have to do to them to make them like the equation. So in this reaction, what do you have that you can use? You have the C, right? Here, you need the C and you need the C, but here the C is 2C. So we need to divide this by 2 to make it 1C. So C, reaction 1, it's divided by 2. C, it becomes C. Half H2 gives you half C2H2. Now for reaction 2. Reaction 2, you can get the CO2 out of it. So to get the CO2, you need to multiply your whole... You need to divide your whole equation by 2 again. So all of this, again, divided by 2. So half C2H2 plus 5O2 gives you CO2 plus half H2O. You're going to ask me why is the half H2O crossed on? You're going to see in a minute. So now we found the CO2 and the CO2. Now what's left is the oxygen. So to find the oxygen, we need to reverse the equation. You're going to ask why. You're going to know in a second. You reverse the equation, and again, you divide by 2. So now reverse the equation. It's gonna become half H2O gives you half H2 plus O2. Now see here, we have two H2Os. We don't want the H2Os. You don't need them. That's why you divided your equation by 2. To get this H2O like this H2O, so you can now just both cancel this H2O with this H2O. And now you're left with this equation. So now what we're gonna do is you're gonna see, you have in every single equation, what did you do? You divided by 2, صح? Yeah. See, you divided by 2 3 times. So just half, and then you put all of your energies. Negative 1, 3. But this one, just you put it as a positive because you flipped the equation for this one. But the rest, just put them as it is, and that's how you get the answer to A. Now to get the answer to part B, which is here, just do this, put this into your calculator. You're gonna get the answer, negative 393. Okay, so now moving on to the next question. Okay, so for the next question, it's asking you to express per mole of N2, the reaction per mole of N2. So you want 1 mole of N2. So what do you have to do to cancel this half, or like 1 over 2? You multiply by 2, so you cancel 2 by 2 and you get 1. So if you multiply one thing by 2, you multiply everything here, everything by times 2. And they wanted reaction of heat. They want the heat of reaction, which means you have to put this inside your equation. So N2 times 3H2, and by the way, you put it in the product side because it's negative. Negative means it's exothermic. And by the way, you also never put the negative sign in your equation because you can't have a negative heat. This here is only to show you if it's endothermic or exothermic, which here it's exothermic if it's negative, and endothermic if it's positive. So 2NH3 when you multiplied it by 2, and now you also have to multiply this by 2 before putting it in your equation. So plus 92. Okay, so now when we go to part 2 of the question, they're just asking you to put it in the form of delta H, which means you give back its sign and you put it as the same, because 2 moles of NH3 go up, and H3 has 1 mole here, so you also multiply everything by 2. So this time you just give it its sign back because you're putting it in the form of delta H equals. You're not putting it in your equation. So now on to the next question. Okay, so for this question, just memorize that the energy needed to separate two hydrogen nuclei apart is called bond energy, which is the energy that separates the bonds from each other. The change in heat content is symbolized by, just memorize these questions. Here, Hess's law states that the heat revolved or absorbed by a reaction is independent of the path followed. It only depends on the initial reactants and the final products and on their states. Just memorize this question, like I said, because it's a law. A group of students were asked to measure the amount of heat generated during a reaction. How should they go with the experimental procedure? They should measure the change in temperature inside of a bomb calorimeter in which the volume of the system remains constant. Again, just memorize it. Okay, so for this question, we did it last week, but I'm gonna re-explain it for the people that didn't get it. So you need to see what types of bonds you have. So you have 1, 2, 3, 4 of this bond and 1 of this bond. See? So 4 times the CH bond, which is 413, you put it in your equation. Oh wait, this is wrong. This should be 4 here. This should be 4, sorry guys. Anyways, so 4 times 413 plus 602, which is the CC, this thing. Sorry. So see this thing, and you need this bond, which is ClCl 240. So these, when you add them all together, you're gonna get 2,494, which are your bonds broken. Now here again you have 4 CH bonds, so it's also 4 times 413 plus 346, which is your CC bond, CC 346, and 2 CCLs. So again, when you do this all in your calculator, you're gonna get 2,652, and we know that the formula is bonds broken minus bonds formed. So when you put this all in your calculator, you're gonna get negative 158. For significant figures, 0.0. We did this last week. Anyways, next question. Again, it's Hess's law, another question though. So again, put the equation you want in the end on the top here, like you did here. So here's the equation you need to get. For the first equation, reverse it, because you want O2. You want O2 in your reactants, so you have to reverse it, and you want to cancel O3, so again, also you have to reverse it. And you have to divide it by 2, because you want this O3 to match this O3. So reverse the first equation and divide by 2. So this is what you get when you divide it and reverse it. Yeah, I don't know why I put it O over 3, but this line was a mistake. It's O3. So again, like I said, just reverse the first equation and divide it by 2, and don't forget to do the same to your heat of formation and make it positive, because you flip the equation. Now for the second reaction, you have to you don't have to do anything to it actually, because NO, see, it matches the NO here, and the NO2 matches the NO2. So just cancel this with this and add your two reaction heats together. You're gonna get your answer to be negative 91.5. So now on to the next question. Okay, for this one, like again, calorimetry is the measurement of reaction heat. Memorize it. To change the temperature of a particular calorimeter in the water it contains by 1 degrees requires 5 kilojoules to complete the combustion of 7 grams of ethane gas. So here they gave you 5 kilojoules and 5 degrees Celsius and 7 grams of ethane gas. You need to combust this much. They're asking you what's going to be your delta H. So we know that the equation is delta H equals negative Q over N, which is C delta T M over N. So you do it all in your calculator. You put down all the numbers in your calculator. You're going to get negative 100. We did this also last week again. We're repeating it again. So here you have another one of Hess's law, another Hess law question. So to get this equation, you need to write it again at the top, and we now need to see what you need to do to each equation. So CO here is in the reactants. This one is definitely not in the reactants, so you have to flip the first equation only. And flip the sign of its heat of formation also. And for the second equation, you do nothing to it, because you have CO2 in the right spot. And the O2s, just see when you add them, when you're gonna cancel them out, like with each other, one O2 minus half of O2 gives you half of O2. So you don't really have to do anything to the O2s. So now you have these two numbers for your heat of formations, add them together, you're gonna get negative 283. So that's your answer. Okay, so for this equation, just rewrite the equation, but they want you to rewrite it putting this inside your equation and with whole numbers. So to get whole numbers, it means not a fraction. You can't have a fraction. So to cancel the fraction, you need to multiply everything by 2. And like I said again, this equation is exothermic because you have a negative here. But when you put it inside the equation, it becomes endothermic. And if you multiply everything in here by 2, you also have to multiply this by 2. See? This is your equation in the end. 2C plus O2 gives you 2CO2 plus 220 kilojoules. Now on to the next question. Again, here they just want you to reverse it. They don't want you to put the energy value in without including its energy value. Reverse it, just make it SO2 gives you S and O2. And for the part 2, they want you to give you the delta H of the reverse reaction. When you reverse it, you change the sign. That's the only thing that happens. So it becomes 297. So for the next question, again, this question is exactly like the one we saw up here in question 13. You need to do the exact same thing, which is delta H gives you negative C delta T over M, which gives you negative 5 times 7 over 3.5 over 28. Put this in your calculator, you're going to get negative 280 as your answer. Now on to the last question. Last question, okay, yeah. You need the heat change when 3.2 grams of methane are burned in excess oxygen. So here, if you realize, it's like what we did last year with the RRGR. So just you copy down what you need. They gave you methane, so you put down on your paper CH4, which is methane, CH4, and you put down your energy, because that's what you need to find. So write down the mass of ethane, the molar mass, which you find by the given, which is 16, and you write down what they gave you. 3.2 grams are used. And you write down your energy as it is, and you cross multiply. So 3.2 times a negative 819 divide 16. You're gonna get on your calculator you're gonna get positive, sorry. Oh no, it's negative. But when you put it on your calculator, I don't put the negative signs. But you put them, don't forget them. So here it's negative 163.8 you're gonna get when you put it in your calculator. They said to 3 significant figures to round it up to 164, and you write it down with the negative sign. And yeah, that's it for the chemistry quiz. This is the end of it, and bye.